from the St. Francis Yacht Club in San Francisco, this is the Wednesday Yachting Luncheon, hosted by Ron Young.
Welcome to the Wednesday Yachting Luncheon. Fun to be here looking out our beautiful windows at San Francisco Bay, never more radiant, sun shining, and here we are in Indian summer. This is the very best weather in San Francisco, and so this is also Fleet Week, and we just came back, many of us from the Stag Cruise, and there were 400 people from all over the world there. It was a really great event, and there were terrific lighthouse speakers. We had 11 lighthouse speakers, headlined by Cam Lewis. And if you are a great sailor, you just took a breath, because Cam Lewis was at one point the greatest sailor alive. It used to be said that if you won the Finn World Championship, you were the greatest sailor alive. So he won it in 79, and then he won it in 80, back to back. That's a nice point. And then Jimmy Carter said, no Olympics for America. So Cam jumped over to the 505, and in 81, he won the World Championships. In 82, he won the World Championships with two different skippers. So that was pretty amazing. And then he went on to win the America's Cup. We've all heard of that. And then just to be really clear about things, he won and set the new record for nonstop around the world, broke the mythical 80-day record that had been in place for hundreds of years, and did it in 79 days, and then, of course, became a Rolex Yachtsman of the Year. So he was the head of 11 great speakers we had up at Lighthouse Talks. So a little bit about our speaker today. So she was born in landlocked Phoenix, Arizona. Just imagine, given what she would ultimately go off to do. She got interested in the water in the ocean when her family vacationed at the top of the Sea of Cortez, and she got very interested as a young child. And when it came time to go to college, she'd already been sort of studying whales casually, but she got her degree in biology, general biology, and then she switched and went to San Diego, University of San Diego, where she got a degree in marine biology with a specialty in aquaacoustics, and that's a very important topic, as you're going to learn. Lots of great research is being done on acoustics, what animals, the sounds they're making, what of those are language, what of those are locating prey, what of those are locating objects they don't want to bump into, and so on. While she was at the University of San Diego, she met a professor that really, really knocked her socks off, and she followed that professor to a career at NOAA. So she's one of the amazing scientists that we have at NOAA. And America is blessed by having an amazing scientific community overall, and especially the scientific community at NOAA. They give us all of our weather information, all of our environmental information, all of our atmospheric information. And if you're sailing around in the ocean all the time, you learn that they're the people you want to call when you see a whale and you want to learn about what's going on in the ocean. So in her career at NOAA, she spends a couple months a year at sea studying animals, and she began to specialize in the right whale. And you'll say to yourself, I never heard of a right whale before. Well, that's maybe because they are the rarest whales on the planet. And we're going to ask her all about why they are rare and how they've gone from tens of thousands in the population down to literally less than 50. That's a really startling number to say, but literally that's been happening inside. So she is, in fact, one of the premier experts on right whales. Please welcome Jessica Crance. Jessica.
Great. Thank you, everyone, so much. It's an absolute pleasure to be here today. And I suspect this is a slightly different topic than what you guys are used to watching in these weekly seminars. I always like to start with a quick show of hands. Has anyone here actually heard of a right whale before? Oh, okay, great. A few of you. Excellent. So for those who aren't familiar, right whales are a very large, robust baleen whale. So they are filter feeders. They feed primarily on copepods and euphausiids, primarily this little copepod here, Calanus. And there are 3 different species of right whales. You have the southern right whale down in the Southern Ocean, the North Atlantic right whale, which is probably the one most of you have heard about, over in the Atlantic on the East Coast. But there's also a Pacific right whale that is found in the Pacific Ocean. And that's the one that I'm going to be talking to you guys about today. So it's primarily found in the North Pacific and the Bering Sea. The North Pacific right whale is split into two different populations. You have the western North Pacific right whale that is found in the waters of Russia and Japan. And then you have the eastern North Pacific right whale that's found in U.S. waters and along the west coast of North America. And the eastern population is the one I'm going to be focusing on today. That's one in our U.S. waters. So right whales were once widely distributed throughout the entire North Pacific and Bering Sea. Then they became the target of Yankee whaling in the 1800s. And it's estimated that between 26 and 37,000 animals were taken, with most of that happening within just a couple of decades. And then that brought the population down to what we suspect was maybe the high hundreds. But then in the 1960s, the Soviets began hunting them illegally, and they took an additional over 700 animals. That just decimated what was left of the population and brought them down to their current numbers. So what are their current numbers? Well, for a couple of decades in the late 20th century, NOAA did several surveys throughout the Bering Sea and the Gulf of Alaska. This plot shows all of the sightings they found in 20-odd years of effort. Based on these data, we had an abundance estimate of only 31 animals. And while this data represents just the Bering Sea population, the sightings outside of that are so rare that we suspect the overall population is not considerably more. So fewer than 50 animals or so remaining within the eastern population. And that does make it, unfortunately, the rarest whale population in the world. And furthermore, as if that wasn't bad enough, there are only about 8 females that we found, with an estimated 2-to-1 male bias sex ratio. And recently, we were able to reanalyze a bunch of genetic samples that we had, historic and more recent ones. It's actually closer to 3-to-1 male biased, which unfortunately is the opposite ratio you want when you're trying to rebuild a population. So based on that, in 2008, NOAA designated 2 areas of critical habitat for North Pacific right whales. There's a primary one in the southeastern Bering Sea, and then a smaller one off Kodiak Island in the Gulf of Alaska. And so while we know these animals can be found in these waters every summer and fall, it's their known feeding grounds, what we don't know is where these animals go when or even if they leave the Bering Sea. Their migratory routes, their calving grounds, breeding grounds, all of it remain a complete mystery. And even if you look at those old whaling logbooks from the 1800s, even the logbooks say there was no evidence that they found calving grounds anywhere in the North Pacific. So it's this big question mark. There are these basic life history questions about this species that we still don't know. We do suspect that they migrate, much like many of your other large baleen whales do. On the left there you can see we did have one high to low latitude match. An animal that was seen in Hawaii in 1996 was later resighted in July of that same year up in the Bering Sea. That remains to this day the first and only high to low latitude match we've had of a right whale. There have been a handful of sightings along the coast of California and Mexico, so that suggests maybe there is a north to south migratory movement. But again, we don't really know. And then in 2021, during one of our surveys in the Gulf of Alaska, we had 2 sightings of 4 right whales, which was a pretty substantial number given the Gulf of Alaska. And one of these animals had actually been sighted a couple months earlier off the coast of Haida Gwaii, off British Columbia. And so this represents the first time an animal from the Gulf of Alaska has ever been seen anywhere else. And so this is a map of all of our North Pacific right whale sightings. We suspect that within this population, there may actually be 2 different subgroups, a Bering Sea group and a Gulf of Alaska group. And the reason we suspect this is that despite all of our photographs and our catalog that we have, there's never been a photographic match between the 2 areas. An animal seen in the Gulf has never been seen in the Bering Sea, and vice versa. We do think that if there are these 2 different subgroups, perhaps they have different migratory routes. Maybe our Bering Sea group is going south to Hawaii like the one animal did, and perhaps our Gulf of Alaska group is moving towards the west coast of North America. But with an N of 1 in either case, it's all just hypothesis at this point. And then in February of 2022, we got some really amazing footage of 2 skim-feeding right whales in Unimac Pass, which is one of the major thoroughfares through the Aleutian Islands chain. So this suggests that maybe some portion of the population isn't migrating. Maybe they do stay overwinter in the Bering Sea. This was the first evidence that we had of feeding overwinter in the Bering Sea, and it was a really fantastic example of a collaboration between institutions and commercial fisheries. This was submitted by a cod fisher. So you might ask, why don't we put satellite tags on these animals, right? So we can track their movements. So we did that. We put some tags out in 2004, and then again in 2008 and 2009, we were able to tag 5 different right whales, and we got some really amazing fine-scale habitat use data, and then all the tags fell out before the animals left the Bering Sea, leaving that question of their migratory routes, unfortunately, unknown. So why do we still know so little about this species? Well, to help highlight that, I want to first talk about their Atlantic counterparts. So the North Atlantic right whale, it's a species in the spotlight. Their entire migratory routes are coastal along the east coast of the U.S. At any time of the year, you can go to the east coast and see North Atlantic right whales from shore. Because of this, they're extremely accessible, for better or worse, but they're a very well-studied population. They know how many animals they have, who's reproducing, who's dying, what the population trends are. So because they're so coastal, while that leads to challenges with their population, it also means that they're very well-studied. Our population, unfortunately, is kind of the complete opposite of that. So the only place we know they can be found with any certainty is in Alaska. It's an extremely large, remote region. It's very difficult logistically to get to. And within their critical habitat, where they are concentrated the most, is a full day's steam from the nearest port of Dutch Harbor, which is at that yellow star. So very remote, difficult to get to. And then the Bering Sea can be fickle at the best of times and downright nasty at the worst of times. This is actual footage from one of our right whale surveys. Imagine trying to see anything in this, let alone a whale that tends to disappear. So I always like to kind of put it in perspective how rare these animals are. You're talking 30 animals in a massive Bering Sea. So I always like to tell you right whales by the numbers. So as mentioned, I've been going out to sea for 14 years, minus 1 year for COVID, and it totals about 637 days at sea. Some of those were in the high Arctic or other areas. So if you narrow that down to just those days where I was in right whale habitat, it's about 504 days total. Of those 504 days, I've been in the presence of a right whale on 24. And I've seen, I think, more right whales than almost anyone at this point. And then we went 5 years without a single sighting. But even then, because you're dealing with the survivors of a population that was decimated by vessels, they really don't like boats. As soon as we get near them, their behavior becomes evasive, they start swimming away. They're extremely difficult animals to work. So of those 24 days, I've been in the presence of a right whale for a combined total of 74 hours and 45 minutes. So about 3.1 days out of 504. So that's the real challenge. You know, how do you study an animal that you can't find in an area that's difficult to get to logistically? And then if you are lucky enough to find them and be in their presence, because they are evasive and not a big fan of boats, they're extremely low profile, the Bering Sea is foggy, so you don't get clear photos. Or my personal favorite, oh, it's gone. Well, there was an animal, or a photo of a right whale swimming away from you, so all you see is the blowhole. So these photos are enough to say, yes, that is a right whale, but not good enough for any kind of photographic identification purposes. So how do you study whales like this, right, where they're extremely rare, you can only get up there once or twice a year? So we use passive acoustics, which is kind of our bread and butter with my group at NOAA that we do. Luckily, right whales are very vocal. They make predominantly 3 call types. The first is rather appropriately named a gunshot call. I'll play that for you now. also how I keep my audience awake. So this is their primary call type. This is the one that they use more often than any other call. You can see why it gets its name. They also make what's called an up call, which is down on your lower left. And we think that this call is a contact call that they use to communicate with other right whales. And then finally, they make a series of other moans and tonal calls. Right. So if we hear one of these calls, it's a pretty good indication that we have a right whale in the area. And so we monitor them using two different methods, short-term and long-term. So our short-term monitoring is what we do when we are actually out at sea. We use an instrument called a sonobuoy, which is deployed from the side of a vessel. And this instrument, it's a free-floating hydrophone or a listening device that will transmit audio signals in real time back to our vessel. So we can deploy it while we're transiting underway, and then I can be listening in real time to any sounds that happen. And so if I hear one of those calls, I'll know that there's a right whale somewhere in the vicinity of our sonobuoy. The other good thing is that they have directional capabilities. So if we do start hearing one of these gunshot calls or an up call, we can deploy multiple sonobuoys and then localize or triangulate on the calling whale and then get a position, direct the boat there, and then hopefully from that point we can spot the whale and start collecting data. And these instruments have really been a game changer for our research on trying to find these animals. They've helped increase the number of sightings at least twofold, if not more. So they've really, really been an incredible asset to our research. The other side of our monitoring coin is our long-term passive acoustic monitoring. And so with this, because we can only get up to Alaska once or maybe twice a year, we want to be able to monitor for these animals year-round, right? We need to know what's happening in those months when we can't be up there. So we deploy these instruments called moorings, where they sit on the ocean floor, and they sit in an array. You can see a diagram of it there. And they sit out for a full year, recording any sounds to an internal hard drive. Then we can return the following year, retrieve the instrument, and start analyzing those data. And so everywhere that you see a circle on that map is where we have one of these instruments currently deployed. Some are also deployed with oceanographic instrumentation, which allows us to then correlate marine mammal presence with oceanographic conditions. And so this is really our bread and butter, and what we spend most of our time on is analyzing these moorings, because we have so many of them deployed that we can tell what species are where migration routes and distribution patterns are, whether those are changing over time. So it's a really fantastic way to monitor for anything that makes sound in the ocean over a very large scale, both temporally and spatially. So I just want to run through a little bit of some of the results we can get from these. What you're looking at is the acoustic results from one location for 2 years of data, from September of 2014 to September of 2016. Your black vertical bars are your percentage of recording intervals with right whale calls. So it's basically a proxy for right whale presence. The blue line is your percent ice concentration. And so what you can see is that in the summer and the fall, we have right whales at this location, which is in their critical habitat. But now you can zoom out and look at multiple years and multiple locations. So these are all of our recorders in the Bering Sea on the shelf. And what you can see when you kind of zoom out like this is that we have very consistent, regular right whale calls every summer at those recorders that are in or near their critical habitat. So that's great. That's where we expect them to be. They're there every year. Fantastic. We're also starting to see an increase in right whale presence at some of our northern Bering locations. These are areas where historically there weren't a lot of takes. We weren't really expecting them, but we're starting to see them moving farther north. And I'll get to possible explanations in a little bit, so keep that in the back of your mind. But like everything with this species, it also comes with complications. One of our colleagues sent us a sound file and said, "What is this?" And we said, "Easy, right whale gunshot." And she said, "Nope, that's a bowhead whale. That was recorded off Utqiagvik, or Barrow, in Alaska." And then if you look at, this is a spectrogram or a visual representation of their sound. This is a beautiful example of bowhead whale song. So bowheads will migrate down into right whale habitat over winter. And right in the middle of this bowhead whale song are 3 textbook right whale upcalls. So are these right whales that are upcalling and potentially gunshotting over winter, or are they bowheads? And so now if we go back to our long-term data, all of these recordings here and these vocalizations that are under the ice over winter, we don't know if these are right whales or bowheads. So for right now, they're just being called ambiguous or maybe until we can find a better means of distinguishing between them. So I get asked quite frequently, why hasn't this population recovered? They've been protected since the 70s. Many other species of animals have been able to recover from a similar situation. Why hasn't this population? Well, that's $1 million question. Unfortunately, we don't know. I mentioned earlier, the abundance estimate that we have is about 30 animals for the Bering Sea. With that, 8 females and a 3-to-1 male bias sex ratio. So right away, the odds are stacked against them. There are very few. It's male biased, not many females. Since 2004, only 4 known females have been sighted. And with that, we don't know how many females are still reproductively active. We don't know whether right whales go into senescence or menopause, basically. So it's possible that these 4 females also aren't reproducing. We were able, with 2 surveys we did in 2017 and 18, we were able to collect 6 new biopsy samples. And what that is just a small little sample of skin and blubber from a whale, from which we can extract a whole wealth of information about their DNA, their sex, reproductive status, their diets. And from these new biopsy samples, of the 6 we collected, 5 were males and only 1 was female. So it really does look like there's this heavy skew towards males within this population. And unfortunately, we have not seen a calf in this population since 2004. We have, however, seen 3 non-adults. We've had 2 juveniles and 1 subadult, 3 different sightings over the past 15, 20 years. These animals were calves at one point. So I think one of the bigger questions that we should be asking is, where are the cow-calf pairs? These animals were seen when they had already been weaned and were no longer with their mother. But they were calves with moms at one point. So perhaps there's some area where the cow-calf pairs are aggregating that we just don't know where yet. So that's our hope. We're trying to answer this question, where are the cow-calf pairs? Because we're not seeing them. So what threats does this population face? A big one is entanglements. So we have only 1 animal in our catalog that has clear entanglement scars, which is this animal that was seen off the coast of British Columbia. The rest of the animals in our catalog are beautifully healthy and robust. But does that mean they're not getting entangled? So this is a screenshot from a video that made the rounds on social media a while back of 3 western North Pacific right whales. So this was taken off Russia, but we have on this, you can see the white scars on the back and then down by their tails. That is very clear entanglement scarring, very similar to what we see with the Atlantic right whales. So we know it's a problem with western Pacific right whales. We know it's a problem with North Atlantic right whales. What we don't know is the actual direct impacts that it's having on our population. Are they not getting entangled, or are they getting entangled, but they're so remote and so rare that they're dying before it's being sighted and reported? We don't know. Similarly with vessel strikes, it's a massive problem for the North Atlantic right whale population. This map shows those 2 yellow stars are where we have 2 of our long-term acoustic recorders, and the one on the right is in Unimac Pass, which is part of the Great Circle shipping route, vessels that go from North America over towards Russia and Asia. And so you can see this is a spatial density map. It basically concatenates all of the vessel traffic within a year and plots it on one map. And so when you overlay the location of our recorders, we have right whale detections on those recorders in this pass where the amount of ship traffic is just astronomical. So the overlap and the potential for vessel strikes to be a real problem with these animals is very real. But again, we have a real problem in quantifying those direct impacts. Are they getting struck and not reported, or are they not getting struck? And if you recall that sighting from February of 2022, that sighting was only 30 or 40 miles to the northeast of Unimak Pass, of that major shipping route. So it's a very real problem, a very real threat, but we've been unable to quantify it up until this point. So another question I get asked a lot is, how is climate change impacting this population? So this plot shows the average temperature change according to the baseline from about 60, 70 years ago. And you can see that the Arctic is warming faster than any other location on the planet. And when you look at the Bering Sea, this plot shows the change in overall percent ice cover. So sea ice comes all the way down into the Bering Sea every winter. And the extent of that changes annually, but in recent years you can see the sharp decline in the percent of sea ice cover. And then here, this shows bottom sea temperatures for 2010, which was a cold year, versus 2019, which was one of the warmest on record. And so you can see that the temperatures in the Bering Sea are warming. So what effect does this have on our right whales? Some colleagues at NOAA studied the impacts of the different ocean climate regimes on copepods, which is the main primary prey for right whales. And what they found is that in cold years, it favors large, lipid-rich, nice, healthy copepod prey. But in the warmer years, you're seeing the prey are smaller, less lipid-rich, and therefore of a poorer quality for right whales. So when you tie that back in to the distribution of the temperatures and the distribution of prey, in those warmer years, we saw right whales that were moving farther north on our acoustic recorders. It's possible that they're following these colder waters up to more lipid-rich and more high-quality prey. So we're starting to see potentially a shift in their distribution as they're having to follow the colder water to find better quality prey. But we are still trying to understand the complexities of that relationship, but that's looking like the trend. Okay, so I'm going to shift tactics just a little bit here and really talk about how to identify them. So they are very large, dark in color. They have a wide, flat back with no dorsal fin. So you're used to seeing dorsal fins on humpback whales or fin whales. These guys have a very broad, flat back. They have these white bumps on the top of their head that are called callosities. And these are in a very specific pattern that's unique to each individual whale. So it's much like their fingerprint. And a fun fact, the callosities, they're roughened skin patches. They're kind of like calluses. The reason they're often white or orange in color is because they're covered in cyanids or sea lice. So sometimes they'll be white, sometimes orange, sometimes black, depending on the amount, the species of whale lice on them. So they also have a really distinct V-shaped blow. So you can see in this photo the two plumes of their blow are separated all the way down to the blowhole, and that's really unique for this species. They also have really broad, flat flukes with a really deep notch in the middle. And then their pectoral fins, or their front flippers, have this really unique shape to them, a paddle shape. And so I always like to throw a few photos up here of right whales compared to species that they're often confused with. So you can see that the callosities on a right whale are very different from the bumps or nodules that you see on a humpback whale, and they're very different from that white-gray coloring that you see on a gray whale. And then again, looking at their blows, that right whale has a beautiful deep V to it, whereas your humpbacks don't, and then your gray whales have more of a heart-shaped blow. You can see the blows are connected kind of halfway down. And we don't use blows as a diagnostic feature because it's very much dependent on the angle of the whale and any wind conditions. But if you happen to see behind it that nice beautiful V, then you got a right whale. And then I always like to say, if you see a whale and you find yourself saying, well, that's a really funny looking gray whale or funny looking humpback whale, odds are it's probably not, and it might be one of these animals. So why is this so important? Well, we have had 2 sightings in recent years right near in this backyard. The first one in April 2022, right off Año Nuevo. Beautiful footage of a skim-feeding right whale. And then most recently in March of this year, right off Monterey Bay, we had another right whale sighting. So these animals aren't just in Alaskan waters. They're not just up in their feeding grounds. They frequently by right whale standards, will be seen off the coast of California and Baja. And I really want to emphasize, the importance of these sightings and identifying it. So here's a photo of a right whale that was seen off La Jolla, California in 2017. Well, here's the whole image from a news story that morning that called it a gray whale. And it wasn't until drone footage of the animal surfaced on social media that we were able to say, that's a right whale. But by then the animal had left the area. We were unable to study it. And so it asks the question, how many others have been misidentified? How many sightings could we have been missing? And so what you can do, the biggest thing is to keep an eye out when you guys are out on the water. Anyone who's out on the water could also be eyes for us. Every sighting of these animals is so rare and so important at helping us answer these questions about where they go and what they're doing. And also tell people about this animal, increasing outreach and letting everyone know to be on the lookout for it. It really does help increase these what we call extraliminal sightings, these sightings outside of Alaska. And that's just one more piece of the puzzle of where these animals are going. And I just want to highlight, again, the number of sightings that have been off the coast of California all the way down to Baja. So they are seen right here off the coast. And with that, I think I'm close to my time. I'll leave it here. Here's what to do. If you see a right whale, there are a couple email addresses and a phone call. If you're able to take photos of the head and get those callosity patterns, that's perfect. And please report them. We'd love to hear all about it. And with that, thank you all so much for your time. Really appreciate it.
Terrific, Jessica. Okay, so why do we need whales?
Well, in the broad sense, whales are a pretty critical part of the ecosystem. There are actually many studies coming out now that show just how important whales are at putting nutrients back into the ecosystem and feeding that primary productivity. So they're a keystone species.
How much does let's get some scale. How long are right whales and how much do they weigh?
Right whales can be up to about 60 feet long, and I believe weigh up to around 100 tons. They're big animals.
And how much do they eat per day?
Ooh, that is a great question. I don't know.
One previous speaker did a study on how much they eat and how much they excrete, and pointed out that when we started losing the whale population, the subsequent downstream nutrients that come out of whales influence the smaller fish population everywhere. So talk a little bit about how whales essentially nourish the environment that they live in.
Absolutely. So whale excrement has a lot of nutrients in it, and in certain areas you are limited by specific nutrients, iron, nitrogen, phosphate. And so whales, when they poop, basically, they are putting those nutrients back into the water column, and then those nutrients are used by your phytoplankton, which are eaten by zooplankton, and so it ends up driving primary productivity.
So how long do whales live?
It depends on the species. Some
right whales.
Right whales, we don't know is the short answer. The long answer, we suspect they can live to be at least 100 years old, potentially more.
And when they have calves, how many do they usually have at a time?
Usually one at a time, and roughly every 3 years or so.
And how long does the calf stay with the mother?
I believe it stays with the mother for about a year and a half, give or take. And this is all based on Atlantic right whales, because we don't really know for our population.
No, I'm going to keep asking questions, but if we see a question in the audience, I want you to have the opportunity. Just hold up your hand and we'll bring a mic to you. So when the calf is with the mother, in this early adolescent stage. How does the mother help the calf? How does she support the calf?
She supports them by protecting the calf and by feeding them. The calf will stay with the mother for 2 years, drinking milk and taking advantage of the protection of having a large whale there.
Who are the predators that she's protecting calves from?
Killer whales are a big one, but then with the other population, you do have vessel strikes, and so having a larger whale there makes them more visible and would help protect them from that as well.
How is it that the whale can get hit? Well, first of all, how fast do whales swim?
Right whales can swim, I think, a maximum of around 20 kilometers an hour. Don't quote me on that. But generally speaking, they are slow moving.
And so how is it that the whale gets hit by a ship? How come they don't see or sense the presence of the ship before the accident, before the whale strike?
They can hear the vessel. They probably wouldn't see it until it was much closer. But when vessels are moving very quickly, especially your large shipping containers, a lot of times they don't have time to move out of the way.
Are there mermaids?
No.
What animal in the sea confused ancient mariners to think about these other non-existent things called mermaids?
I think most of those tales were based on manatees or dugongs.
Now, what do whales eat, especially right whales?
Right whales eat primarily zooplankton with a focus on copepods and euphausids. So tiny little shrimp, basically.
And what's the size of these tiny feeding shrimp?
Very, very little.
Like smaller than a finger?
Yes.
Finger size. And do they filter feed? How do they?
They do filter feed. Right whales are baleen whales, so they'll gulp big mouthfuls of water, and then they have baleen hanging down in their mouth. They'll push the water out, and then it traps all the krill in the baleen that they can then eat.
So wait, so they scoop them up with their mouth open, and then they get rid of the water, and they filter it out, and the difference is the food that's in them. Now, we do have a question from the audience. Yes?
Many years ago, I was racing on a sailboat down to Santa Cruz. And it's a memorable experience because I was up on the bow watching dolphin play with the water. And all of a sudden I noticed that there was a different dolphin there. And it had no dorsal fin. It was very distinctive. No dorsal fin, dark and black on the top and white on the bottom.
Yes.
And so when I got to Santa Cruz and I talked about it, there were people there that said, "Oh, you saw a right whale dolphin."
Correct. Yep.
Is there any relationship to those?
No relation. That's a small dolphin, part of the toothed whale family. They just share a similar name, but they're a beautiful animal.
So with the light behind you, I can't see. Is this Sally that's asking this question?
Yeah.
This is Sally DeWitt. Terrific, Sally DeWitt.
Thank you.
Wonderful. We all miss Jimmy.
Yes, we do.
Jimmy DeWitt, one of the great sailors in the history of America, was our member for many years and passed away half a year or so ago. Almost a year ago. We have a question over here too. So I'm going to keep asking questions. Okay, Sharon, yes.
Okay, yeah. Of course, it's very concerning to hear how small the population is. And how do you think your research will help you improve that, and what could help improve the population of those whales?
Yeah, it's a great question. What we need most at this stage is information. If we know where calving grounds are, where their migratory routes are, then we can work to maybe put legislation into effect in those areas that would then help eliminate potential threats within that region. But until we can get to that point, we need to know more about where they go.
Do they have a protected area now at all?
They do have the two critical habitat areas, one in the southeastern Bering Sea and then one off Kodiak Island. There aren't currently any legislative actions in place within those regions yet, though.
So are the Russians still hunting whales?
We don't have any evidence that they are.
John, there's a question over by the bar.
I have a question.
Yeah.
Is there a tipping point in the number of individuals where it gets harder and harder for the species to recover? And did that happen because of whaling?
There is a tipping point. I think it's very species dependent. In our case, despite the low number and the male bias sex ratio, there is quite a bit of genetic diversity still within this population. And other species have been able to recover from animals, or from sizes in the tens of animals. So there is still hope, absolutely.
Do we know how deep they dive, and what do they do on those dives?
Yeah, so we think they keep their dives to, if I recall, on average 200 meters or so. They aren't often found in waters deeper than that. And usually when they're doing the deep dives, they're foraging. They're looking for food.
Stay within the food column.
Yep, they'll go wherever the food are. Sometimes food is concentrated at the surface, and so you'll see them kind of skimming at the surface with their mouth open. If it's distributed throughout the water column, they'll go where the food is.
How often do they have to breathe oxygen?
I think they can hold their breath. Well, I know they can for at least kind of 12 to 15 minutes. We suspect maybe up to 20 minutes or so.
Another question from the audience.
Is the Atlantic population equally endangered, and are they genetically similar or the same?
They are genetically distinct. The Atlantic population, last I heard, numbered around 330 or 340 animals. So they are also endangered, but that population is doing better than ours. Unfortunately, they know that that population is declining pretty rapidly.
Okay, their vocalizations. What's the evidence that some of those vocalizations are communications and or sonar, learning where fish are, or learning where objects they don't want to hit are? What's our evidence for those three types of vocalizations or purposes for vocalizations?
The only way you can know for sure is to be able to record the sounds while you're witnessing whales' behavior. So we've heard sounds that are produced while whales are interacting, so you can assume that that has some kind of behavior mediation effect. Others are assumed behavior with the specific call type if it's recorded on their feeding grounds. Baleen whales don't use echolocation like your toothed whales do, like a killer whale does, but it's possible that they're using acoustic cues from some of these calls to get information about their environment.
Can the Atlantic right whales breed with the Pacific if they ever had the opportunity?
If they had the opportunity, they probably could. They are all distinct genetically. Even the western population of North Pacific right whales is genetically distinct from the eastern. So there's potential for overlap between the two North Pacific populations, but it appears even that means that they aren't interbreeding.
Are there any attempts to repopulate by kind of artificially, mating them up? Is there a Match.com for whales?
I wish there was a Match.com. Unfortunately, you're dealing with very large, rare, wild animals, so it's unfortunately not that simple.
When I ask about the predators, prioritize predators, you said killer whales are a predator. Are there other predators?
Not that we know of. We do see evidence of what we call rake marks, which is basically tooth marks on right whale flukes, so we know that killer whales are chomping at them, but we don't know of any other natural predators.
How do they fight back if they're attacked by a killer whale?
So right whales will, you hear about the fight or flight response. Right whales, because they're so big and robust, will be part of the fight back response, as opposed to like a long, slender whale that might try and flee.
So how do they fight?
They have extremely large flukes. Their tails are about the third length of their whole body, the width of them, so they can slash and throw their tail around and throw their weight around.
Has anyone witnessed the birth of a whale?
Of one of our right whales?
Yeah.
Not that I know of.
What about whales in general?
There have been a lot of instances of extremely fresh neonates, meaning born within a few minutes or hours. There have been, on very rare occasions, a few sightings of whales giving birth, but more often than not, what you're seeing is evidence of birth that had just taken place.
So the signature whistles that the whales make, Do you have any indication that they have unique identities? That is to say, I, as one of the whales, recognize, Bill or John or Fred. Do they have a name? Do we have any idea that they have names yet?
For our right whales, we don't know. I suspect they do. They have to have some way of acknowledging and recognizing different individuals. We don't know what that is yet for our population, but other species like bottlenose dolphins, you can.
John?
Is there a research fleet that you work with, and is there anything that the yachting boater can do to monitor or study the situation?
Yeah, we don't work with specific fleets, but we always say, keep an eye out and look out for these animals. It's the best thing that can be done at this point is to help us identify sightings and where they're at. And then if we have colleagues in the area that happen to have vessels, we might be able to then get out and work the animal as well.
So this question was asked of you at lunch by Diego Mendoza, a member of the committee, and he said, what's the highlight of your career? Good question.
That was a very good question, a difficult one to answer. I think the main highlight is in 2017, during a survey of the Eastern Bering Sea, we found 15 right whales in that one survey, which is, I think, the second highest ever recorded for a single survey. And we found a juvenile during that survey. That was one of the juveniles that we found. And the knowledge that we gained from that survey, the biopsy samples and the photo ID was phenomenal.
What are the Russians or others who hunt them harvesting? What do they get from the whale they catch?
When they catch whales, they're usually going for the blubber and the oil. These days, they'll also go for meat for certain species. Back in the 1800s, they would use baleen to go into anything from combs to corsets. These days, the right whales have been protected since the 1970s, though.
You mentioned weaning. Now, weaning I associate with a mammal weaning with the breast and the offspring. Mm-hmm. Well, how's the weaning process in the case of the whale?
Very similar. When they're first born, they feed exclusively from their mother's milk, and then over time they slowly learn how to find prey patches, and then they'll shift from only drinking milk to a mixed diet, and then eventually will be feeding on their own.
So the whales have boobs?
Mm-hmm.
They do. How many?
Well, so females will have genital slits, and the milk comes out of the slits. Okay. So you'll see the calf come up underneath the whale, and then it's getting milk from those slits.
Uh-huh. Would we recognize it as milk? Is it white?
Mm-hmm. Yep.
So when you're out on these trips, how many people are usually on a research project with you, and what's the different roles that they have on your team?
So there are a variety of different types of surveys that we do. If it's strictly a marine mammal survey, we can have anywhere from 10 to 15 scientists. Some are visual observers, so they'll be scanning with big eye binoculars. Some are acousticians like myself. If we have room, we'll also bring oceanographers on board so that we can correlate oceanographic data with our sighting data. We'll also bring zooplankton specialists, so we can do zooplankton net tows and try and get prey samples.
Diego has a question.
You mentioned the 3-to-1 bias. Is that something that could change with more offspring, or is that set in stone?
It absolutely could change. And it's possible, too, that our sampling of the population was not random. If the cow-calf pairs are aggregating somewhere else and only the males tend to be aggregating in the Bering Sea, that automatically biases our sampling. So it is very possible that ratio could change, yes.
So we've had a previous Wednesday Yachting Luncheon speaker who demonstrated with video evidence that whales can hunt in pairs. And he showed videos of bubble netting. That is to say, one whale in the pair that we're hunting would swim in a spiral, and as they blew out air, they created basically an air column, and the prey would go away from those bubbles to the center of the column, and a separate whale that wasn't blowing these out would come up with a mouth open and go up follow the column up. And he demonstrated that they must have had some way to basically communicate with each other with their action or with some other way to communicate, because they weren't going straight up and down. They were going off like this, following the spiral of the bubbles.
Yeah, bubble feeding, it's a really beautiful sight to behold. With right whales, they don't do bubble feeding. We do see them often in kind of tandem diving when they're going down deep, so they could be feeding side by side. But we don't have any evidence yet that our population has any kind of coordinated foraging in the way that you would see bubble netting.
So how do they hunt in pairs, and do they more often hunt in pairs than not?
We will often see right whales as solo animals. So sometimes they're in pairs, sometimes they're as solo animals. That may or may not be correlated to foraging. We don't know.
Is there any evidence that whales communicate with other animals acoustically?
You do see whales with different species. Right whales are often seen with humpbacks and fin whales. We're still trying to learn what that interspecies communication might look or sound like. You do also see large pods of dolphins of mixed species, so it looks like they're interacting, but we just don't know how.
John has a question.
There's another question from online from Kathy Trafton. She asked, if we think we have spotted a North Pacific right whale, especially if we have images, how should we report this sighting?
I'm very glad someone asked that, so I get to repeat it. The easiest email you can remember, np.rw for North Pacific.rightwhale at NOAA.gov, NOAA.gov. It's an email line that will be automatically forwarded to several of us in the research community. And so we will know right away if you've got, or as close to right away as we can. And then hopefully we can reach out and start that communication channel.
How old are right whales as a species compared to other species of whales?
As a species, I don't know. Honestly, I've never had that question. They are very old.
Are they older than gray whales evolutionarily?
I think they all started branching around the same time, but evolution is not in my wheelhouse, so I'm not entirely sure.
So are they older than the average member of our yacht club?
Very much so. That I can confirm.
So what size boats, when you go out on an expedition, what size boat does NOAA usually commission?
For our expeditions up there, because it is remote and we're out for long stretches, we're usually on vessels in excess of 150 feet.
Now, I understand from NOAA scientist Mark Miller, who's been to several Wednesday yachting luncheons, that NOAA wants other smaller research vessels to be available, and that in fact there's a scarcity of research vessels to align with research projects. There is a growing list of research projects given the new awareness of environmental issues, and that's caused NOAA not to have enough ships, and furthermore the ships that NOAA usually builds are a couple 200 feet, and he says there's a lot of need for boats that are 80, 90, even 65 feet.
Yes, so we often will have to charter vessels because we only have so many NOAA research vessels, and that can't compete with the number of surveys. So we do often charter vessels, and we are always looking for people to apply to become a charter so that we can use that. Absolutely.
And am I right in guessing that would be trips up into Alaska?
Most often, yes. For our work in our region, it would be trips to Alaska, yeah.
So which politicians support research on whales?
Typically, those who are environmentally conscious and are environmental stewards, those are the politicians that tend to support marine mammal research more.
Would you like to feature mention any names?
I would not at this time.
Diego.
You mentioned you're going to be speaking at the Smithsonian. Congratulations.
Thank you.
Would you care to share what topics you're going to touch on that day?
Absolutely. So in a few months, we will be having a symposium at the Smithsonian Institute. We will be highlighting 3 species of marine mammal that are currently endangered and highlighting the research efforts and the impacts of the Environmental Protection Act on our conservation efforts. So the 3 species will be the North Pacific right whale, the North Atlantic right whale, and a new species called the Rice's whale that was recently discovered in the Gulf of Mexico.
So you mentioned that the habitat of right whales is mostly north. You postulated that some how that could be related to a warming planet where it's getting warmer. But you said that the top of the Earth is getting warmer than the middle. Why wouldn't that send the right whales south to stay in the same cold water?
Because their prey are not moving south. The temperatures to the south, yes, they're warming more slowly, but they're already warmer than the temperatures in the north. So their prey are far north, but they don't move south because of the temperatures down south. So they only move north where they're getting colder.
Now, in the life of a whale, a right whale, how far? What's the range of the individual whale's habitat?
For ours, it could be several thousand kilometers. I think the greatest migrations are usually from gray whales, and they go from up north off Alaska near Utqiagvik or Barrow, and they go all the way down to Baja, Mexico every year. So individual whales can make extremely long migrations.
Alaska to Baja.
Yep.
Okay.
Every year.
And they're following prey?
They are going down to Baja to breed and calve, and then going back up to their feeding grounds in Alaska.
What's more romantic about Cabo?
Better views, warmer water.
Diego has a question.
So, since you're probably in the water a lot, when you are exposed to other species of whales, do other folks or scientists expect you or would like you to collect data for them?
We do often collaborate quite a bit, yes. So we'll go out on other cruises if there's room. If we can, we will deploy instruments for other colleagues or collect other types of data. Yes, ship time is difficult to come by, so we very much collaborate as much as we can when we're up there.
There's another question online.
Great.
Is there an effort being made to bank the DNA?
Yes, so during the talk I mentioned genetic biopsy samples that we get. So it's a small little plug of skin and blubber. We keep those. They stay frozen. We can continue to access those DNA and those samples and continue to do research years after we've initially collected them. Absolutely.
What institutions are prominent in whale research?
Quite a few. You've got obviously NOAA, you have universities, quite a few universities.
Which ones?
Woods Hole Oceanographic Institution on the East Coast. You've got Scripps Institution of Oceanography, quite a few in Oregon. There are universities all over the coast that are really active in it.
Is there any nationality bias to research? Are the Americans ahead compared to the French or the English?
I don't think that any one nationality is ahead. Everyone's doing research in their region. The species that are there and the environmental conditions are different for each country, so it's difficult to have any kind of standard for one nation.
Are right whales in any way ever endangering humans?
The one way that comes to mind is if they are entangled and entanglement rescue efforts are underway. These animals are very large and they can thrash around as we're trying to release them from any entangled gear. That can be a very, very dangerous job and a very dangerous effort to try and do. So that's probably the biggest risk is any kind of entanglement research.
So that means that when we were around them and trying to untangle them, people could get hurt.
Correct.
But independent of that, is there any way that whales hurt people?
None that really come to mind. Mm-mm.
So a couple years ago, about 12 years ago, we had a speaker who was racing back from the Farallones on a J35 going downwind on a port jibe, the spinnaker up, and they got attacked from the starboard side by a whale who hit them 5 times, was the topic of the WYL.
Yeah.
Talk about that.
There are situations where some species have been known to hit boats. There's some killer whales that have been hitting some yachts. There are rare instances like that. Generally speaking, human and large whale interactions are pretty rare. But yes, it's not zero.
Are sharks a predator of whales?
Not that we have a lot of evidence of. They will certainly be seen feeding on carcasses, and they will take advantage of any dead whales. But we haven't seen a lot of evidence that sharks are predators for whales.
So are killer whales whales?
Killer whales are technically, yes, whales. They are part of the toothed whale family, even though they are a dolphin. It's kind of a whole
So they're
taxonomy.
somewhere between dolphins and whales, but they have teeth. They're not filter feeders.
Correct, yes. So within the world of whales, dolphins, and porpoises, you have baleen whales and toothed whales. And within the toothed whales, you have, your dolphin family. And killer whales are the largest member of the dolphin family. So they have teeth. They do not filter feed.
And how big are they?
Killer whales, the largest ones, can get to be, I think, around 27 feet long.
So when they attack a 60-foot whale, where do they attack it?
They'll hunt in pods and kind of tag team it. And for example, when they're hunting a gray whale, they'll often try and force the whale underwater. They'll separate cows from their calves, and then take turns trying to exhaust and then drown the animal usually.
And then drown it by keeping it down, by attacking it downward.
Yep.
So Jessica Crance, what an amazingly thoughtful, smart scientist you are. And it's been great. We're very happy you shared your insights with the Wednesday Yachting Luncheon.
Thank you.
Thank you so much.
Thank you. It's my pleasure.
Yeah, great. And with that, we adjourn the luncheon.
This has been a presentation of the Wednesday Yachting Luncheon.